Welcome to the lecture series of Computer Networks. I am Harsh Khattar, working as Assistant Professor in Department of Computer Science at KITE Group of Institutions, Ghaziabad. In previous lectures, we have seen the basics of OSI reference model, and now gradually we are increasing towards the layer wise functioning. Today, our highlighted topic is physical layer and how the transmission media works. As you all are aware, in OSI reference model, we have 7 layers. When we are transferring our message to the receiver end, our message is passing through the 7 layers starting from the application layer and goes down towards the physical layer, and then the communication channel is there where my message is kept and traveling via the medium and then reach to the receiver end. So, the same thing is highlighted here in this figure. You can see here when we are talking about the sender side, a message is traveling here. Suppose I am sending a hi message and this message is traveling from the topmost layer, application layer, and gradually coming down to the physical layer. Here the important part about the physical layer is this transmission medium. I am messaging to my friend hi, but this hi means English word is not going to travel through the physical medium. The data is now converted to the bit stream and then the signals, and those signals are now transferred from sender side application to physical layer and then physical layer to the receiver and physical layer. So, the same thing you are seeing here, this layer wise layer approach is followed. The upward layer, application layer, then the presentation and so on, and then finally the physical layer is present here, which is taking the data word, making it into the bits and signal, and finally in the physical medium they are sending the signals to the receiver end. Here this bit stream is treated as the input for the physical layer, and the output of physical layer is the signal which is traveling through this particular medium. This is what physical layer is performing, and when the same data is received here at the physical layer at receiver end, it is moving upward towards the application layer, and then my friend who is at the receiver end will receive this hi message. So, this is the workflow. This is how the physical layer is working. If I talk about the university question, in university there is a one prominent question: what is the role of physical layer? What are the roles and responsibilities of physical layer? As I said, the basic communication between the sender and receiver depends on the data which is transmitting from one end to the another. Suppose this message is moving from sender to receiver. In this case, the physical layer is performing various functionalities. Number one, it is checking the physical transmission medium. The medium can be a wired or wireless. So, here in the coming slides we will talk about the transmission media. If I talk about the other roles and responsibilities, so sends data bits from one device to another device, which is the primary objective. The data is coming layer by layer, and the major part is from one end to the another end how the data is transferring. So, the main task is performed by the physical layer. Another important thing is maintain the data rate. We have seen nowadays there is a gradual variation between the data speeds, but I am sending a message. So, my message transfer is dependent on the data speed. If the data speed varies, it means the delay is there. So, here the physical layer is maintaining the data rate between the end users, and the data is transferring from one end to the another end in a flexible manner. Another important thing is the synchronization part of bits between the sender and receiver. This synchronization part is very important. Suppose I am sending the bits and my bits are received in the random order. Suppose I am sending a message hi, which is converted to the signals or bits. Suppose my message to be sent is something mentioned here, and if some of the bits are shuffled, then there is no use of the message. If the semantics are going to be changed, then we can say the my message, which was hello or hi message, is not reaching at this point appropriately. So this is the major issue. So this issue is also dealt by the physical layer. Another important thing is the topology implementations. In previous lectures, we have already discussed about the network devices and topology. So topology means how the devices are connected. It is not possible always that the devices are connected in the wired medium. If I am using my mobile phone and sending the messages to my other friends, so they are also using the wireless channel. The communication is through the wireless medium. So in this case, these type of topologies are very important, and based on the topologies, based on the organization of the devices, how they are connected, physical layer is responding. So this is the adaptive nature of physical layer. Another important thing is the communication of data streams over the physical medium. It is not like that the single message is coming and it is transferring to the receiver end. No, we can also send the data stream, means the multiple messages together. So in this case, there is no crossover, the crosstalk of the messages, there is no such interference. So everything is taken care by the physical layer. So this is the beauty of the physical layer, that physical layer performs all these functionalities. Yes, on another manner, you can say another question in the university exam, what are the services provided by the physical layer? Then you can say, yes, the physical layer provides the better transfer of message from receiver end, from sender end to the receiver end. You can also mention the synchronization of the bits, the synchronization of the data streams are done by the physical layer. So these are the services. Similarly, you can mold the question and say what are the functionalities of physical layer. You can also use these 5 points. You can add some more with this example in the exam, that yes, these are the functionalities of physical layer. What the physical layer is performing is in front of you. So this is the basic idea about the physical layer. Now what are the concern points? Physical layer is performing based on the concern points. If there is a change in the topology, then the role of physical layer also being molded. So here, as I said, the network devices and the topology are already covered here in the lecture number 5. In this lecture, we are focusing on the transmission medium, and in the next class, we will talk about the transmission switching method, at the how the message is going and through which switching method the message is delivering. So right now I am focusing on the next part, which is the transmission medium. Before starting to the transmission medium, let's take one more example about the physical layer. Suppose I am sending one data. Suppose the same hello message I am transferring from sender side to the receiver end. My topology is changing, means I am traveling via a road and the network is changing. In this case, my mobile device, in my mobile device I am using one application. Through the application layer I am sending a hello message, and based on this hello, the data stream is generated and the physical layer converting this data stream into the signals. In this case, how the data is transferring from sender side from my mobile to my friend's mobile is through the physical layer. So I hope now you all are clear about the role of physical layer. Sometimes we are studying the theoretical part and we are unable to understand what is the importance of this particular layer. So I hope now it is very clear that what is the exact role and responsibility of physical layer. The transmission of data from one end to another. This is in single line. Now based on this transmission, we need to choose how we are transferring the data. Either I am sending a data through a wired channel or wireless channel. Yes, 2-3 decades back we can say that most of the devices are connected through the wired medium, but currently we are dependent on the wireless. So, let us have a look towards the type of transmission media. Either we are talking about the wired or wireless, then we will talk about the detailed part of wired mediums, what are the wired mediums which are available and what are the other methods which are in wireless flexibility. Transmission media. Transmission media says through which medium you are transferring the data. Suppose I am talking about the wired medium or another part is wireless. Wired medium says yes, the message is traveling inside something, means we have a cladding, we have some wires and the data is flowing inside this. So, this is also known as guided media. Might be in university exam you will see there is a topic explain the guided media or wired media. So, both are the same words. Another one is the unguided media. Unguided media means the data is flowing in the air through some electromagnetic waves. So, we will see in detail how the data is traveling through the air or through some guided medium. Guided mediums are majorly divided into 3 parts. I am saying majorly because now there are so many types of cables available in the market, but majorly we are talking about the 3: twisted pair, coaxial cable and the optical fiber. These are the 3 main guided mediums, means the wired cables which we are using for the network topology purpose. In case of unguided media or we can say the wireless medium, we can say we have the electromagnetic waves through which our data is going to travel. So, again there are 3 main categories. Number 1, radio waves, another one microwave and we have the infrared waves. So, this is all about the transmission media. Let us have a look if there is a question on the detailed part, because in the syllabus there is a specific topic transmission media and in university exam you will find 5 marks question on this about the detailed part. So, let us have a look towards the guided media and unguided media. First we talk about the guided media. Most commonly used cable is the twisted pair cable. This twisted pair cable is basically a crossover of the 2 wires together, which is twisted in such a manner to avoid the interference of the signals. You will see in many areas these twisted pairs are applied basically in the appliances for the flow of electricity. Similarly, we can also use for the data transfer. Can we use the same cable of electricity for the data transfer? Yes, for the shorter distance. We will also discuss about the advantages and disadvantages of twisted pair, but what exactly twisted pair performs? It is very economical. There is a crossover of the 2 wires which we are seeing in this manner. You can see here, yes, this type of connections are there and the data flow, the flow of signals is through these cables. The cable is a type of wiring with 2 conductors twisted together. As I said, the crossover is there, it is clearly mentioned here, the crosswalk is there, which is the noise generated by the adjacent pairs. So, for this we are using the, and it is a most commonly used one. Here the major issue is the attenuation. So, what attenuation is? When we are sending the data. So, in this case there is some sort of electromagnetic interference. In this case we need the amplification of the signals after every 200 meters. So, for the shorter distance we can use this. So, if I talk about the clear advantages and disadvantages of twisted pair, it is highlighted here that the advantage is cost effective, it is reliable for the shorter distance, easy for the installation purpose because the availability of the cable is very easy, suitable for the shorter distance. If I talk about the demerit, the first demerit is we need the amplifiers for the longer distance. If the distance is more than 200 meters between the 2 devices, then we need to amplify the signal. Attenuation basically means when the signal is traveling, then some sort of distortion is there. The attenuation says the signal is a bit lost. So, we need to amplify it. So, for this we need amplifiers. So, here it is not durable for the longer distance. The quality is not as such that you can trust that yes, the signal is there, and the tempering is very easy in this. Higher attenuation, so amplification is required, and there is some sort of interference. So, this is the issue with the twisted pair. Another category is again the well known use for the transfer of data. Most of the spaces in the television set you will see these type of coaxial cables. This is also known as coax cable. So, might be you will see terminology coax in this. Coaxial fiber is typically designed for the transmission of high level signals. Suppose we are talking about the dish TVs. So, in this dish TVs right now we are using the coaxial cable. In this cable you can see there is a cladding, there is a shield, and you can see there is a center conductor, and the data is transferring through this. So, the issue which was there with the twisted pair, the more attenuation was there. So, it is quite less. It is much durable than the twisted pair, but with these functionalities the price will above the twisted pair. So, if I talk about what is the beauty about the coax cable, it supports the longer cable length between the devices. So, previously which was the 200 meters, now we can use it for the kilometers purpose, and for this we can use for the communication purpose. It comprises of the round copper conductor, 3 layers of insulation and the shielding. So, this insulation and shielding helps in the lesser attenuation, and the interference is very less in comparison to the twisted pair. So, these are the advantages and disadvantages. As I said, it is quite durable in comparison to the twisted pair. You can see here the coaxial cable is not affected by the magnetic field because of 3 layers and the of insulation and the shield. You can see here it performs better for the shorter distance. So, the performance which was there in the shorter distance about the twisted pair, here the performance is much better if I am using the coaxial cable. Yes, no doubt there is a disadvantage, it is quite costlier than the twisted pair because we are using so many insulation layers and the shields. So, we can say the signal is lost over the longer distance. When we have the multiple buildings in a college, now the distance between the one campus and the another campus is between the kilometers or more than a kilometers in this case. Now, it is not good to use the coaxial cable because for the longer distance again there is a distortion of the signal. The signal tends to be leaked at the point of egress. When you are adding or you are clubbing the two cables at that particular point, there is a leak of the signal. So, this is not appropriate to use some sort of leakage points in between the cables. So, for this we need to be concerned about this. Then the another important factor is under the heavy usage, if the data transfer is continuous. So, in this case under the fluctuations the speed varies. So, this is again one issue in the coaxial cable. So, now we are moving towards the another cable type which is the optical fiber. Now, we are seeing all the broadbands are using the fiber optics. So, here this fiber optic cable or the optical fiber is used for the better delivery of the data under these all are under the guided, means the wired cables. Okay. So, here the fiber optic cable is the Ethernet cable which is we are using here under the physical layer for the transmission of data, and under the glass there is a light wave which is traveling. So, here there is a better speed, better transfer of data in comparison to the coaxial cable and the twisted pair. So, it is clearly mentioned here that here we have the pulse of light through the tiny tubes of glass. So, you can see here there is a visibility that these are the glass tubes. If you have closely observed the optical fiber, if the broadband is installed at your home, then you can see there is a very thin wire, and under this you can see there is some sort of thread. So, these are the basically those tiny tubes, and between this the data is traveling in the form of light. So, this is how the data is traveling through the fiber optic. If I talk about the advantage and disadvantage, as I said, the advantage is basically the better reliability, the better speed, better bandwidth of data, safer transfer of data, but in the same manner we can say the cost is much more than the other two which we have studied. So, in this case you can get the highest bandwidth over the coaxial and twisted pair. This is the electromagnetic interference resistance. You can see the higher performance for the longer distance, even for the 10 kilometers, 100 kilometers you can use this cable. But there is a issue of cut and damage. It is not easy to install. For this there is a special machine and you need a special device to connect these cables for the installation purpose. If I talk about the twisted pair, it is very easy to install. Coaxial, yes, you can also install it easily, but the fiber optic is not in the category of twisted pair and the coaxial in terms of installation and ease of maintenance. So, this is all about the guided transmission media, means the wired one. Now, if I talk about the unguided transmission media, so yes, most of the now devices are through the unguided transmission media. Here we have three categories. Number one, which are the radio waves, then the microwaves and the infrared. These all wireless waves are related to the electromagnetic waves. These are the three categories based on the frequencies the data is traveling. So, here we have seen that the data is transferred over the wireless medium, unguided medium. So, how the data is transferred? Here the frequencies are set, and to the specific frequency, to the specific spectrum, the data is traveling in the air through these electromagnetic waves. If I talk about the radio wave, the frequency range is basically the 1 kilohertz to 3 kilohertz. Most of the work is under the 3 kilohertz. The radio waves are omnidirectional and the signals are propagated in all the directional frequency ranges from 1 to 3 kilohertz. Microwaves are the different alarming ones which are used frequently from 1 gigahertz to the 1000 gigahertz. These are basically under two categories. One is the terrestrial and another one is the satellite microwave. When we talk about the satellite communication, radar communication, then we are using these type of waves. Another important one is the infrared, but it is only for the shorter distances. We have seen in our remotes, we have seen this in the mobiles, we have the infrared waves, and these are for the shorter distance, and the frequency range is from the 300 gigahertz to the 400 terahertz. So, this is much more than this. So, this is all about the unguided transmission media. Now, so this is what we have discussed. Now, what is the outcome of this? If I talk about what we have discussed in this class is about the physical layer. Previously, we have talked about the network devices. What are the devices which are there inside the physical layer? The topologies. Now, we have related the topology under this physical layer. Now, the other topics which we have covered for the university purpose is discuss different types of transmission media. So, you will get 2 marks or 3 marks question in the university exam or subordinating with the 5 marks question, that what are the different types of transmission media, what is the difference between the two types of cables, what is the difference between the wired or guided unguided medium. So, these can be. And there is one important question for you: if you are creating your own network, what type of transmission you prefer? That you are using a guided medium or unguided medium, means the scenarios are very common we are using. So, this is an open ended question for you. Just try by your own. If you are making your own network, then which transmission media you choose and why? What is the reason behind this? Means the reliability, the cost and the secure data transmission. So, this is all about the today's class. Thank you. In next class, we will talk about the transmission.